In this video, we're going to work with monomials. You may recall that to find the LCD with variables, use the highest exponent. Be sure to check for reducing by factoring. The numerator and the denominator. In example 1, notice that our denominator is an x squared. And likewise down here we have to the first power and to the second power. Because we're supposed to take the highest exponents when we're trying to find the LCD, we know that our LCD is going to be x to the second, or x squared. That's what we'll multiply to each term in the numerator and the denominator. Notice that when we do this, some of our x squareds will divide out. So we get x squared times 1, which is x squared, minus 9, because these x squareds divide out. 1x divides with 1x here, and we're left with just an x. So that gives us just x times 1 plus, notice these x squareds also divide out, and we're just left with 3. At this point, it's important to recognize that this x squared minus 9 is a difference of squares that factors to x plus 3 times x minus 3. Since that factors in the numerator, we have a common factor in the denominator that divides out. This is very important to recognize. X plus 3 divided by x plus 3 is 1. And same in the denominator, x plus 3 divided by x plus 3 is 1. So when we rewrite it in its most reduced form, we do not write anything in the denominator, because if it's over 1, we don't have to write anything. So it's x minus 3 over 1, or just x minus 3 as my solution. In example 2, we again need to look for the highest exponents to determine what our LCD is. Our LCD in example 2 is x to the third, y to the third, since those are my highest exponents. When I multiply those through to each term in my numerator and denominator, my denominators will divide out. From here, I'll rewrite as I divide out the common factors. X to the third divides with y to the third divides with y to the third, and I'm left with x to the third in the numerator. And x to the third divides with x to the third, and I'm left with negative y to the third. And this is all over x to the second divides with x to the third, and I'm left with an x in the numerator, and y to the third divides with y to the third. And then I'm left with x in the numerator of the denominator. Then, on the other term in the denominator, I have x to the third dividing with x to the third, and 2 y's divide out, and I'm left with 1 y in the denominator. So my other piece of the denominator is negative y. X minus y does not factor further. However, a difference of cubes is factorable. This factors to x minus y, x squared plus x times y minus y squared. So since I've factored the difference of cubes, I can now divide out the common factor between the numerator and the denominator. This gives me a final answer of x squared plus xy minus y squared, which doesn't factor further.